After a few years at the Applied Psychology Unit, I moved to a teaching post at the University of Sussex. And my then boss said, you ought to apply for a grant. Why don't you apply for a grant? So I applied for a grant to look at the relationship between long-term and short-term memory. And I asked for a postdoc and a research assistant, and they cut the research assistant but allowed me a postdoc. And the person I appointed was Graham Hitch. Now, at that time, short-term memory research had become rather unpopular. It had become very messy. There were many similar models and not much ability to separate them. And there was also some rather, there were two problems with the models. They all more or less approximated to the most influential of these, which was a model by Atkinson and Shiffrin, which became known as a modal model because it was kind of in the middle and like all the others approximated to. And this assumed that information fed through a series of sensory buffers, visual iconic memory, auditory echoic memory, into a unitary store that acted as a working memory. Now, the term working memory had been invented in 1960, but not really used. I think it was first used by Atkinson and Shiffrin, who used it as a label, but didn't actually expand. The idea of a working memory is that it's a temporary memory system that you use in order to help you do other complicated cognitive tasks. So like reasoning, like learning, like comprehending. And the Atkinson and Shiffrin model assumed that it acted as a working memory. There were two problems with it. One was its assumption about learning. It assumed that the more time you held something in this temporary memory, the better you learned it. And it didn't matter what you do, just hold it. In fact, it turns out that simply holding it by saying it to yourself, for example, is a very inefficient way of learning. And as Craik and Lockhart demonstrated in their levels of processing paper, the more deeply you think about something, the more deeply you process it, the better you learn it. So if you show somebody a word and just ask them, is it in capital letters or not, they'll remember very little about that word. If you ask them, does it rhyme with the word dog, they'll do a bit better. But if you ask them something about its meaning, is it a pleasant word? Does it fit into the sentence, the man kicked the, then they'll remember it very much better. So that actually disenchanted a lot of people with the original model. As far as I was concerned, one of the crucial problems came from neuropsychology. An important component of the attempt to distinguish between long and short-term memory had come through the study of single case patients. So, for example, the study by Brenda Milner of patient HM, who had had an operation to retrieve to treat intractable epilepsy. And this had involved removing tissue from his brain bilaterally on both sides, and in particular from an area called the hippocampus. This resulted in relieving his fits, but making him densely amnesic. But nevertheless, his ability to hear and repeat back a telephone number was fine, so he seemed to have reasonable short-term memory. Some work that I'd done with Elizabeth Warrington in London had expanded this by taking a number of the tasks that had been used to separate long-term and short-term memory in the general cognitive literature and testing these on a group of very pure amnesics. A very pure amnesic is someone who has a dense deficit in the capacity to learn and recall new material, but who is otherwise intact. So their intelligence is fine, their perception, their language, everything is intact except for this very dense and very precise memory deficit. Now, at the same time, Elizabeth Warrington and Tim Shallis studied an exactly complementary case of someone whose long-term memory is fine, but whose ability to repeat back a telephone number was limited to 1 or 2 digits. So one had what was called a double dissociation. One group that could do A but not B, another group that could do B but not A. So that was regarded, and is still regarded, as powerful evidence in favour of a separation between A and B. Now, one prediction that one could make from this, if you use the Atkinson and Shiffrin model, is that the patient with grossly impaired short-term memory should also have a bad working memory and should have difficulty in learning because they assumed that the information came through this working memory. And these patients didn't. Their learning was pretty normal, their language was normal, their intelligence was normal. These are, understand, carefully selected patients. If you just take a patient off the ward and hope, then usually brain damage is general, you get a complicated result. But particularly in these early days, we learnt a lot from carefully selecting patients that allowed us, in a sense, to do an experiment of nature in which you pull apart 2 crucial variables. Now, by finding this patient who didn't behave according to Atkinson and Shiffrin, this seemed to cast doubt on the whole idea of a working memory. So what we decided to do was to try and tackle the question of what's memory for, what's working memory for. Now, we didn't have access to these rare patients, but what we decided to do instead was to try and take our student subjects and make them into patients. And we did this not by clunking them on the head, but by giving them a task that would use up that part of their brain or that part of their mind. So we said one task that uses short-term memory is digit span, memory for sequences of numbers. So what we will do is we will take some tasks that are assumed to depend on working memory, reasoning, learning, comprehension, and we'll have our subjects do these at the same time as they're holding and repeating sequences of digits ranging from 0 up to 8. So our subjects would be saying 5, 7, 9, 6, 3, well, meanwhile looking at a reasoning task and trying to solve it. What we found was that we'd rather expected our task to wipe out performance. It didn't. It had a very clear effect. The effect was greater, the greater the number of digits held, but errors were the same. People were just slower. And this held across all of our 3 tasks we looked at. So we reckoned that we had to complicate the picture. So we decided we'd guess on what it needed to do this. And we proposed 3 components. One was an attentional component, the central executive, and we thought that this would run the show. This was supplemented by a verbal component that we thought was what was defective in the short-term memory patients. And we argued that we probably need a visual equivalent. So we invented one called the visuospatial sketchpad. And then we set out trying to explore these. We were very lucky at the time that I was invited to contribute to a rather influential annual series called Recent Advances in Learning and Memory, or Motivation and Memory. Anyway, Recent Advances. We were rather hesitant because we felt we don't really understand this yet, but it seemed too good an opportunity to miss. And so we wrote a paper, which came out in 1974, called Working Memory. And it's a damn good thing we did, because we still don't understand it, but it's been very influential over the years.